Welcome to the Explainer. Today, we're tackling something absolutely crucial: how to develop a FHIR-based ophthalmology imaging platform for 2026. Look, if you're in healthcare IT or clinical informatics, you already know the ground is shifting beneath our feet, fast. By 2026, the expectation for seamless, AI-ready interoperability, it's going to be through the roof. So we're rolling up our sleeves today to build a clear, highly actionable blueprint for tearing down those stubborn data silos using the latest FHIR and DICOM standards.
Let's kick things off with the elephant in the room. Why, in this era of mind-blowing digital health, are medical images still the most siloed data in healthcare? Seriously, we have these incredibly high-tech PACS systems holding massive, gigabyte-heavy, gorgeous pictures of the eye. But the actual actionable data surrounding those images, it's locked away in a digital vault, totally disconnected from clinical decision-making. It's frustrating, right?
So here is our roadmap for fixing this. We're going to hit 5 key areas today. 1. The ophthalmology data silo. 2. Synergizing FHIR and DICOM. 3. Architecting the cloud pipeline. 4. Mapping pixels to patients. And finally, 5. Implementing eyes on FHIR. All right, jumping right into part 1, the ophthalmology data silo. Let's get to the root of the issue. PACS is fantastic for what it does, saving massive, high-res pixel data. But let's be honest, it just wasn't built for seamless integration with clinical workflows. The real gold, the metadata about the scan, machine settings, the timing, is trapped deep inside those DICOM headers, and anyone who's dealt with this knows those headers are notoriously stubborn to extract and map to an EMR. This fragmentation literally builds a brick wall between the raw image and our holistic view of the patient. There's a recent PLOS One paper that hits the nail right on the head regarding these interoperability hurdles. It points out that mapping messy DICOM metadata to clean FHIR structures is a massive bottleneck. The big takeaway here? Just having standards isn't a magic wand. Standardizing completely falls apart if you don't have a solid overarching architecture and strong governance for things like authorization and data provenance. Which brings us seamlessly to part 2, synergizing FHIR and DICOM. To smash through that bottleneck, we need a two-sides-of-the-coin approach. We're leveraging the legacy power of DICOM alongside the modern, lightweight agility of HL7 FHIR. These are the twin pillars of our platform. We're definitely not tossing DICOM out the window. Instead, we're creating this perfect synergy between the heavy imaging data and the discrete, structured health record data.
Now, to architect this correctly, you've really got to separate these two concepts in your head. Use FHIR strictly for your information-centric workflows. That means EMRs, finding out what studies even exist, and handling the order and report metadata. On the flip side, use DICOM Web for the heavy lifting, the imaging-centric workflows, like pulling from PACS, post-processing, and parsing the actual DICOM instances. Draw a hard line there, and I promise you, your architecture will scale beautifully.
Moving on to part 3, architecting the cloud pipeline.
So what does this actually look like in a modern 2026 cloud environment? Well, if you're using a platform like Azure Health Data Services, you've got a very clear 4-step pipeline. Step 1, deploy your managed services in a single workspace, keeping FHIR and DICOM together. Step 2, upload your imaging studies via DICOM Web. Step 3, you build an analysis pipeline that triggers the moment those uploads hit. And Step 4, you push those resulting clinical insights straight back into your FHIR service.
Let's pop the hood and look at the mechanics of that pipeline. Once you're deployed, your DICOM store uses a change feed. The second a new study arrives, boom, that feed triggers your serverless Azure functions. Those functions can then ping a machine learning endpoint, maybe to flag anomalies in a retinal scan. The results are securely routed back into the FHIR server as a structured observation. And it goes without saying, for 2026, every single byte of this data in transit has to use TLS 1.2 or higher. We absolutely have to keep that PHI locked down.
Okay, part 4, mapping pixels to patients.
So getting the architecture spun up is really only half the battle. We have to actively harmonize the data itself. And this specific mapping strategy is an absolute goldmine for developers. It tells you exactly how to translate those cryptic DICOM header fields into pristine FHIR resources. For example, your DICOM study instance UID maps cleanly to the FHIR imaging study identifier. The structured conclusions from the scan, those map to a diagnostic report using SNOMED CT. And your clinical variables become FHIR observations linked to LOINC codes. This translation layer is exactly how we bridge the gap.
When you get this mapping dialed in and host it on a robust engine like a happy FHIR server,
You finally solved the fragmentation problem. You're giving clinicians a unified, system-agnostic dashboard. Imagine a doctor looking at a patient's vitals, lab results, and the AI-extracted insights from a retinal scan all at the exact same time, in near real time, right inside their native workflow. I mean, that is the true power of mapping pixels to patients.
And finally, Part 5, implementing Eyes on FHIR.
We have to anchor this entire architecture to specific ophthalmology mandates. To make sure your platform's clinical vocabulary actually aligns with global eye care standards, the official HL7 HIIR implementation guide is your true north. See, the Eyes on FHIR initiative kicked off because specialties like ophthalmology really lacked universal guidance. This guide hands you the exact profiles, terminologies, and use cases you need to lock down retinal workflows in a standardized, globally recognized way.
And the best part? We know for a fact this works. At the recent HL7 Connectathon 27, an entire track was dedicated to stress testing this implementation guide. The results completely proved we can hit true, FHIR-driven semantic interoperability between diagnostic devices and EMRs. This isn't just some academic exercise, folks. This push is heavily backed by the American Academy of Ophthalmology and the National Eye Institute. The whole specialty is moving in this direction, uniformly.
Listen, building this out isn't just some nice-to-have technical luxury. As this FDA mandate makes crystal clear, driving better patient outcomes literally requires medical devices to be inherently interoperable with health IT systems. Adopting a FHIR-based platform is a strict regulatory necessity for the future of digital health. You are building for compliance just as much as you're building for clinical excellence.
As we wrap up this explainer, I want to leave you with a challenge. Take a hard look at your current imaging systems, your PACS, your EMR integrations. Ask yourself, how quickly could you implement this 2026 blueprint to tear down your own data silos? Because the standards are here, the cloud architecture is proven, and the regulatory bodies, they're demanding it. The time to start mapping those pixels to your patients is right now. Thanks so much for hanging out with me on this explainer, and let's keep building the future of healthcare.